Tonight, whatever you eat will come with an invisible safety net you never really think about. A label, an expiration date, a government agency that tested it before it reached your plate. You don't taste test your dinner for poison. You've never had to. Somebody, somewhere, already did that work for you, using equipment and chemistry you'll never see. For almost the entirety of human existence, none of that existed. Every plant, root, seed, and berry was a genuine gamble, and getting it wrong didn't always mean an upset stomach you could immediately blame on your last meal. Sometimes it meant a slow, silent poisoning that wouldn't show up for years, long after anyone could trace it back to a single meal, a single plant, or a single mistake. So how did people figure out, food by food, plant by plant, generation after generation, exactly what was actually safe to put in their bodies, with no chemistry, no laboratories, and no real way to see a toxin coming? The obvious answer is trial and error. Someone got sick, word spread, everyone avoided that plant from then on. It's a satisfying story, and it's not entirely wrong. It's also, for a huge number of the foods humans actually eat, incomplete in a way that matters. Trial and error works fine when the danger is fast. It falls apart completely when the danger is slow, because trial and error depends on being able to connect a cause to its effect. And some of the most important foods in human history poison you so gradually that no single person, watching carefully over the course of one lifetime, could ever reliably make that connection. To understand why trial and error alone falls short, you have to start with something older than humans entirely: bitterness. Humans have roughly 25 distinct genes dedicated to detecting bitter compounds, part of a family called TAS2R receptors. These genes exist across nearly every backboned animal on Earth, and the pattern is remarkably consistent. Species that eat more plants tend to carry more of these genes. Frogs, which eat a huge range of insects and vegetation, carry dozens. Species that eat almost none, like dolphins, which live almost entirely on fish, have lost nearly all of them. The reason is straightforward. Plants can't run from things that want to eat them, so instead they manufacture chemical weapons, alkaloids, glycosides, compounds built specifically to punish anything that swallows them. And an enormous number of those defensive compounds happen to taste bitter. So evolution built a detector, and a remarkably specific one at that. Long before the first hominin ever stood upright, animals were already carrying an internal alarm system, tuned specifically to the chemical signatures plants use to defend themselves. Different receptors catch different families of toxin, almost like a keyring of separate locks. One responds specifically to strychnine. Another catches the compound class found in willow bark, the same family of chemical that eventually led to aspirin. A third reacts to the sharp, defensive compounds found in mustard and horseradish. This wasn't something any species had to learn through experience. It came pre-installed, hundreds of millions of years old, inherited rather than figured out, sitting in your mouth right now exactly as it sat in the mouths of your ancestors long before they were even primates. Which sounds like it should solve the whole mystery on its own. Bitter equals dangerous, avoid bitter, problem solved, case closed, no further explanation required. Except it doesn't solve the mystery, not even close. Because some of humanity's most important staple foods are, in their raw state, both bitter and genuinely lethal. And bitterness alone doesn't tell you how to fix that. Take cassava, also called manioc, a root vegetable that today feeds hundreds of millions of people across South America, Africa, and Asia, one of the most important staple crops on the planet. Certain varieties of cassava contain cyanogenic compounds that release cyanide when the plant is damaged or digested. Eaten raw, in enough quantity, it can kill you outright. Eaten raw in smaller amounts over months or years, it does something worse. It builds up, slowly, with no obvious symptoms at first, eventually causing nerve damage, paralysis, thyroid problems, and permanent neurological harm, sometimes only appearing after years of a diet that seemed, every single day, to be working just fine. Bitterness would tell you cassava is dangerous. It does. Raw cassava tastes unmistakably bad, sharp, and unpleasant in a way that's hard to ignore. But bitterness can't tell you that partially processing it isn't enough. It can't tell you that boiling alone, which removes most of the bitterness and makes the root taste perfectly fine, still leaves enough cyanide behind to slowly poison you over years of otherwise ordinary meals. And it definitely can't hand you the actual multi-step solution, because that solution isn't written anywhere in the taste of the plant itself. That solution, when anthropologists studied it among indigenous communities in the Colombian Amazon, turned out to be extraordinary. Researcher Joseph Henrich, building on detailed measurements by nutritional anthropologist Dufour, documented the full detoxification process used by Tukanoan communities. Grate the root, wash the pulp, press it, sometimes for hours, to squeeze out the liquid. Let it sit. Boil it. It's genuinely laborious. Dufour's fieldwork found that Tukanoan women spend roughly a quarter of every day on this single task, generation after generation, simply to make their staple food safe. And her measurements showed exactly why every stage matters. The cyanide content drops measurably at each individual step, from grating to pressing to boiling, until what's finally left on the plate is safe to eat every day for an entire lifetime. Here's the detail that makes this genuinely strange. The people performing this process don't need to understand cyanide chemistry to make it work, and historically they didn't, and in many cases still don't need to today. Henrich's argument is that no single person could plausibly have invented this technique through personal trial and error, starting from nothing. The reasoning is simple once you see it laid out. If you skip a step or shorten the process, nothing bad happens right away. You'd eat improperly processed cassava for months, maybe years, feeling completely fine before any symptoms appeared. And even then, connecting a slow neurological illness back to a specific cooking shortcut taken years earlier is close to impossible for any one person to work out alone in one lifetime without the benefit of anyone else's accumulated experience. It's a problem that essentially requires more than one human life to solve. This isn't a hypothetical risk. It's a documented one on a massive scale. When Portuguese traders carried cassava from South America to West Africa centuries ago, introducing it as a new, highly productive crop, they carried the plant itself without the accompanying processing knowledge that had taken the Tukanoans and neighboring peoples countless generations to refine. The result was widespread chronic cyanide poisoning in populations that had inherited no protocol for handling it safely. A public health problem linked to paralysis, goiters, and neurological disease that in some regions persisted for generations before local processing techniques caught up, and in parts of the world remains an active concern even now. The plant crossed an ocean in a matter of weeks. The knowledge needed centuries to catch up to it. So the real answer to how ancient humans knew what was safe to eat isn't one mechanism. It's two, stacked on top of each other, operating on completely different timescales, solving completely different kinds of danger. The first layer is fast and biological. Bitter taste receptors, hundreds of millions of years old, giving an immediate, individual, in-the-moment warning. Don't swallow that. It buys you protection against a huge range of acutely toxic plants, instantly, without anyone having to teach you anything. The same way it protects a frog or a mouse that has never tasted that particular toxin before either. The second layer is slow and cultural. Multi-step processing techniques, refined not by any single genius, but by many generations, quietly making small adjustments, passing the full procedure down essentially as an act of trust, long before anyone understood the chemistry behind why it worked. This layer catches the dangers the first layer is blind to: the slow ones, the cumulative ones, the ones with no immediate taste and no immediate symptom. Nothing an individual lifetime of careful observation could reliably catch on its own, no matter how cautious or attentive that individual happened to be. Modern food safety, the labels, the expiration dates, the regulatory agencies testing chemical composition in laboratories full of equipment no ancient cook ever had access to, is a genuinely recent third layer, built on measurable chemistry rather than instinct or inherited ritual. It's remarkably good at what it does, catching dangers neither of the older systems were ever built to notice. But it's also, by a wide margin, the youngest of the three systems keeping you alive at dinner. A thin and recent addition resting on top of a biological alarm system older than our species, and a body of cultural knowledge older than written language, both of which are still humming along quietly underneath it every time you eat, mostly unnoticed and almost never given any credit. So the next time something tastes bitter and you flinch without thinking about it, or you follow a family recipe exactly, convinced that skipping a step would somehow ruin it even though you couldn't say precisely why, you're not just being picky, and you're not just being sentimental about your grandmother's cooking. You're running two ancient safety systems at once, layered on top of each other without your permission or awareness, working together the way they always have. One older than your species, one older than your family could ever remember learning, quietly protecting you from dangers neither taste nor common sense alone was ever built to catch.